Thank you to the organizers. Thank you for coming. I have some questionable insights coming up from attempts to measure adoption in the Airflow community and beyond. And so I'm all about skepticism, and I encourage you to be skeptical about metrics and what I have to say in general, and just in general in the world. And this is so pedantic, and I apologize. And there's more pedantry to come, unfortunately, because I'm a former teacher, and that's just kind of baked in. So I want to start out in the spirit of skepticism with the idea that Airflow does not exist. And what I mean by that, in all seriousness, is that if we think about analysis and analytics and metrics, a presupposition of that is often that we have a distinct object to study. There's an object over there that we can understand in its kind of totality and independence from us. And I'm skeptical of that notion, and I feel like we should be skeptical of our ability to understand Airflow in such terms. It's kind of the Cartesian baggage, this Cartesian dualism that we've, in other cases, left behind. So I have a few more words to sort of say about that in a frivolous introduction coming up in just a moment. And then I'll talk about Airflow object metrics and what I think is available now in the ecosystem in terms of tooling and an opportunity that may or may not exist around that. And I'm curious what other folks are doing at your companies and organizations around metrics collection. And then this is kind of a user story as well. And so I'm going to share a pipeline that I'm using to collect usage, aka adoption, aka consumption metrics. And basically, the pipeline is a fairly simple ETL pipeline, uses a dynamic DAG to get data from the pipestats.org JSON endpoint, load data into Snowflake, and visualize in Superset. I'm also getting a little data that I still need to automate from BigQuery. And then just initial efforts, just insights. And this is all early days, just so you know. Okay, so this will be a little bit strange because my background is such that until recently I was working mainly on OpenLineage and the Marquez project, which are open source lineage projects that Astronomer also drives. But recently I've focused more on guides around Astro and Airflow. So this is a kind of combination. And I'll be mentioning OpenLineage and the Marquez project as well. So what makes Airflow so difficult to study and even think about in terms of analytics? I think it's a massively distributed system. There are nodes that are widely distributed in a network. And so we might think more fruitfully about it. This is some jargon, some postmodern jargon from the late 60s, but in relational terms, right, as a play of signifiers instead of a simple subject-object relationship. So we should think in relative terms about Airflow. So for example, our objects of analysis are so different depending on where we are and how that constrains what we know. So here's a late 15th century map of the world. This is what we knew about the world at that time. 40 years later, here's a map of the world, early 16th century. What we know about an object is very much determined about where we are. So where are we in relation to Airflow? So here are some data points that are readily available now without much effort. If you think about Airflow and the Airflow community as a community of users, you'll get a quite distinct picture of the community, I would argue, right? So you might go to Slack. One of the largest channels in the Airflow Slack is random. So we have 53,000 as of July in there. Of course, it's a simplification right off the bat to think of that as a user community. So it's difficult. We're necessarily segmenting the community in order to understand who is where and how they're engaging with it. But even in Slack, there are devs. There are devs who are helping users. There are devs discussing Airflow contributions and issues. The same could be said of the star count, which everyone, I think, rightfully maligns, because there's so little effort involved in starring a repo, and what does it even represent? Does it actually represent any form of engagement at all? So I think we should be very skeptical of that. And yet you get a very different picture. I imagine that Ash and Cactual have also starred the repo, right? Very different picture from the website metrics, which are available from the Matomo project. We have 1 million odd users there. And then finally, the code base. If you think of Airflow primarily as a code base rather than a community of users of software, then you have a different picture. So what is Airflow? Maybe in your company, the way you understand Airflow is in terms of what off-the-shelf solutions are getting you through integration. So at Astronomer, for example, we use Common Room. Common Room kind of won the day against Orbit recently. Orbit was, I think, better at visualizing trends in community engagement and membership. But Common Room has some advantages around integrations. There are many built-in integrations there. So for example, you can get a lot of information about engagement on GitHub and Slack, and it's nice to have it in one place along with maybe a CRM that your company is using. Of course, this costs money, right? And then we have Matomo, which I mentioned earlier, which is what Airflow uses currently. It's a arguably more secure alternative to Google Analytics. And so we have quite a bit of data about website traffic there. So I would argue that this is kind of where our analytics are at the moment, because at least in my experience, we don't talk, this is my experience. So your company might have a different approach, but we don't talk too much about consumption or adoption. That's what motivated this project. And let's check in on our DAG. Okay, so the whole point of asking you up front was to avoid this, but the crucial thing I forgot was to play the thing. So what I'll kind of change the order, but what we're getting it, and we'll have the bottleneck here when we're using dynamic task mapping to load the rows into Snowflake using a Snowflake hook. So we'll check back in with this later in a minute. So this is the dynamic DAG, and I know best practices are, dynamic task mapping is to be preferred, but I like being able to see all the DAGs directly in the UI very easily and unpause and pause what I want as I'm adding new projects to this pipeline. And a convenience of it is that I just simply add the project to that array, and then the DAG is automatically generated in Airflow. So simple ETL pipeline, a little neurotic task here where I just have another task that has a select distinct query to load the data into a new table. And so there's some cleanup I need to do. I'd like to add data quality checks, follow more best practices. So anyway, so that's the DAG. Okay, so here's superset. So in visualizing metrics from these projects, notice some things right off the bat, like the relatively flat line in Airflow consumption. We heard a very different number on stage today for the monthly download number, which is interesting, right? I think it was about half. So I remember 26 million. And I think that could be, this is just a guess, that I'm collecting the downloads with and without mirrors from PyPy. So if you do it without mirrors only, then you get about half the number in my experience. I'm also interested in the OpenLineage provider package. Okay, let's check in on our DAG. Still running. Okay, so this is a year's worth of downloads data being loaded into Snowflake, and the reason why it's taking so long is because Snowflake limits your write tasks. So I can only load 19 at a time, the limit is 20. You can set that with an environment variable. The parallelism, Airflow core parallelism environment variable. In an OpenLineage dashboard, we see more trends. It's a much smaller project. Different trends are easy to visualize in Superset. There are some charts that are available. There's some charts that are available just out of the box that make it fairly easy. And I've used SQL Lab to use queries on top of the data that's coming in from Snowflake to add custom data sets to this, which is really convenient as well for the big number monthly one. So big fan of Superset, as you can tell, but let's check in on our DAG. Okay, so on to some insights we should be skeptical of. One thing in trying to track the OpenLineage jar downloads from BigQuery is that we noticed a really interesting thing is represented by this pie chart, which is that 99.77% or 99.8% of the versions are 0.30.1. So right away, this is kind of puzzling. We're on 1.22.1 currently. So why are almost 100% of downloads of OpenLineage jars on this very old version? And so I think there are some actionable insights here. We can reach out to some of our larger partners. We have cloud providers on the project now, and we can ask them, okay, what version are you on? Would you like to unlock some more use cases by upgrading, taking advantage of some of the many new features in the project? And by the way, OpenLineage is an open framework for lineage metadata collection and analysis. We recently onboarded Amazon. They have an integration now they recently announced. So it could be Google is using this version in their product, in Dataplex. So that's kind of something that was interesting out of the project already. Let's check in on our DAG. Okay, so if we go into Snowflake, we're looking for Pydantic. Okay, and as I mentioned, we've got the without and the with mirrors here. So it's fairly easy. I won't take you through the process because it would take too long of adding the data set from Snowflake into Superset and creating a chart. But that's basically the pipeline. So would like to deploy to maybe an EC2 instance, make the code publicly available so others can contribute, take advantage of the GitHub integration, automatic deploys to Astro, would like to move off PyPyStats to the public data sets on BigQuery, and as I mentioned, put the DAGs on GitHub. So that's the project at this point. Thank you.